So the framework made it constructive doable by giving meaning to culture beyond the normative words that describe the teacher. So she offers a discussion of the role taken as the researcher is research for the
Hey everybody, we'll start in literally just 1 minute here.
Rather than getting caught up emotionally in the discussions, she relied on those particular concepts that really helped step back and focus on what it was that she was researching. And the second thing that I wanted to mention,
okay, let's get rocking and rolling. So if nobody has questions just about the course in general, let's give you guys a moment to speak up. Assuming the video was okay, everything went off without a hitch.
Yeah, it was fine for me.
Say again?
It was okay for me.
Okay, good, good. If it was okay for you, then it's especially okay for me. Okay, let's roll through a couple extra questions. I'm thinking I like this format. I don't know what you guys think. Just doing a couple extra questions, giving you guys an opportunity to see a bit more. I always found that to be useful in math classes. So I'll throw this up on our Moodle as well, in case you want to review it or in case you're missing it. So I'll put in a video URL once I actually upload it to YouTube. And I'm just gonna maybe minimize it like this. There we go. Or just entirely get rid of it. Okay, perfect. So I threw together a couple true and false here. I think we can just rip through these probably. So let's give you a moment to just read number one and see what you think. So in your mind, hold the answer. Binomial experiment consists of n independent identical trials, each of which results in either success or failure, and is such that the probability of success on any trial is the same. So it's true or false question. And the answer to this one is true. That is basically the definition of a binomial experiment. So independent trials, all identical, and the results are independent of one another. Okay, so no one trial will affect the results of the next trial. So think like flipping a coin, or whether or not a vaccine works or something, just because I was just reading about that. Those are all binomial experiments. Poisson random variable is a continuous variable that can be used to describe the number of occurrences of an event over a specified interval of time or space. That one's just slightly off. So if you go check out the definition in our notes, this one's false. 3, a discrete random variable may assume a countable number of outcome values. That is true. Okay, so discrete variables are countable. 4, in a binomial experiment, the results of one trial are dependent on the results of other trials. No, that's false. They are independent. No. Is there one more? This is kind of like almost like a multiple choice kind of thing. So which of the following distributions can be used to solve the following problem? So the average number of cars arriving at a drive-through fast food restaurant is 3 in 10 minutes. what's the probability that exactly 4 cars will arrive in a 5-minute interval? So a couple different distributions. There are some of them we know and some of them we don't know. But usually anytime you have something with a time frame, or you're going to have like a time interval, those are going to be Poisson. So I chose to focus a little bit on this kind of question because I know the notes is a little light on it. It sort of is what it is. You can probably expect a question to show up on like a test or a midterm, but to give you an idea of what they can be like, I chose to include number 6 here. So a local bank, and by the way, like I'll throw these up on Moodle besides the video. I think I meant to put I'll try to put the link to these notes in give me just 1 second here. I'll try to put this link in the description of the video. Sorry, I'm a little distracted here. I was actually, yeah, long story. Okay, so a local bank has determined that the number of companies listed in the area declaring bankruptcy follows an approximately Poisson distribution with a mean of 2.6 per year. So 2.6 bankruptcies per year. And what is the probability that exactly 4, that should say bankruptcies, not probabilities. So right here, they should say bankruptcies. Let's see if I can modify that. Okay. They spell bankruptcies like that. There. All right, I'm a math teacher, not an English teacher. Okay, let's go back. All right, so for A, first of all, I'd remind you that on your formula sheet, you have the formula for a Poisson distribution. And it's this one right here. It's kind of tricky to remember, but it's e to the power of negative mu, and then times mu raised to the power of x divided by x factorial. So remember that e is a number. Okay, if you find that button on your calculator, it's like 2.71. It has something to do with the natural logarithm. So if you go e to the 1, you'll get 2.718. So look on your calculator for a button that has like e to the x or something like that. It might be the second function on a button that has an L and an N. So you might find a button that says ln. And if you go second function, you'll usually see that you have that symbol there. It's Euler's number. Okay, so that's sort of the first thing that like makes this formula kind of tricky. Is like, what the heck is this e thing? So you got Euler's number, and then you got the mean, and you got x. So in this particular problem, if you read through it, the mean is 2.6 bankruptcies per year. Okay, so it's 2.6. So what's the probability that exactly 4 bankruptcies occur? So you'd write it like this. You'd write probability that x equals 4. Okay, and you're going to be popping it into this formula. So you're going to go e to the power of negative 2.6 times 2.6 raised to the power of x. So that'd be raised to the power of 4 divided by x factorial. Now x is 4, so you're gonna go 4 factorial. And remember, this doesn't mean like 4, like you're not saying it really loud or something. 4 factorial. Now there's a button on your calculator, but all factorial means is just a fancy way of saying start with 4 and multiply down to 1, decreasing the number by 1 every time. So 4 factorial is the same thing as writing 4 times 3 times 2 times 1. Okay, so it's just a shorthand way of writing multiplication like that. So I went ahead and figured out the numerator. So maybe I'd say take a moment, plug this in on your calculator. Make sure you use that button E. Like when I type in that negative 2.6, and the negative is important. Like just for this number here, I get 0.07427. Okay, that's just for this. And then you're going to multiply it by 2.6 to the power of 4. When you do that, I got 3.3941 divided by 4 factorial, which is 24. Okay, When you finish typing that in on your calculator, I got 0.1414. And I keep saying that we're going to talk about rounding, and we are. Just for right now, in general, like if a question doesn't say what to round to, it's not a bad idea to keep 4 decimal places, okay, or 4 digits after any zeros, all right? But you can also, another thing you can do if the question doesn't say is like look at how many decimals are being kept in the numbers given in the question. So there's like 1 decimal here. Those are just guidelines, but yeah, generally in stats, try to keep 4 decimals, and you'll generally be safe, okay? And again, we will talk more about it later. I just thought I'd point that out in the meantime. Okay, so what does this mean? There's basically a 14% chance that there's exactly 14 bankruptcies during the next year. Let's go ahead and do part B, which is actually, I like part B. I was like, that's kind of tricky, but it's also kind of nice because it brings in a couple concepts. So to do this one, you guys will know from the notes that I talked about the complement rule, where you go 1 minus some probabilities to figure out other probabilities. So in this case, if we're looking for the probability that more than 1 bankruptcy occurs next year, if you start writing it out, so if you're looking for the probability that more than 1, so X is greater than 1. If you start writing out what that means, well, that means that you'd have to do probability of 2 bankruptcies plus probability of 3 plus probability of 4. So more than 1 just means like keep going, right? So 5, 6, 7. So really, when you think about it, ... plus, like when do you really like stop? Like how high does X go? And the answer is like, well, could be 100, right? Could be 1,000. So how are you going to calculate that? There's no easy way to do it unless you're like using a computer or something, unless you use the complement rule. Okay, so if the probability of X being greater than 1 is probability of 2, 3, 4, 5, so on and so forth, then if I were to go 1 minus the probability of everything that is not in here, then I'd be left with everything else, right? That's the complement rule. So what's not included in X greater than 1? Well, that would include probability of 0 bankruptcies plus probability of 1 bankruptcy. So that's the complement rule. So if I can just figure out these 2 things, and knowing that probabilities have to add up to 1, so if I go 1 subtract everything that's not greater than 1, I'll be left with this. I'll be left with 2 and higher. Okay, so that's the tricky part about this question. Okay, so I hope I explained that well. So as long as we can find probability of 0, probability 1, we'll be able to figure out this answer right here. So all that means is that I got to do this same formula twice. Once using X equals 0, and then once using X equal 1. Okay, so let's see if I can squeeze it in right here. So for X equals 0, let's do that one first. So you're going to go e to the negative 2.6 times, now it's, remember the formula is mu, so 2.6 raised to the power of X, and X is 0, divided by X factorial, so 0 factorial. Now, a couple of things about this. Anything raised to the power of 0 is going to be 1. So if you check on your calculator, go 2.6, raise it to the power of 0, you'll get 1. So this is 1. When you plug this in on your calculator, yeah, you basically get 0.1931. Okay, so that's your numerators. This number times 1 divided by, now be careful here. So some of you might get a little scared because you might remember, well, you can't divide by 0, right? You can't take something and divide it into 0 groups. But be careful because this isn't 0. This is 0 factorial, okay? And by definition, if you type in 0 factorial on your calculator, you will get 1. Okay, so 0 factorial is actually defined as 1. It's not the purpose of this course to know why, but it's important that you realize that that's the case. So when you do this, you basically just get 0.1931. There we go. Perfect. Okay, we had a visitor in here. Hang on. Erase this.
Sorry, I didn't mean it.
Oh, that's okay. That is totally okay. You surprised me. I can't, maybe only you can erase it. It's fine. Don't worry about it. I'll use green. Don't you worry about it. It's totally fine. Okay, let's do x equal 1 here. So same procedure. So it's e to the power of negative 2.6 times 2.6 raised to the power of x, or raised to the power of 1 divided by 1 factorial. Now 1 factorial is just 1, and 2.6 raised to the power of 1 is 2.6. So I didn't really show a lot of work for this one. Ooh, did I look at the wrong answer here? Yeah, I made a mistake here. I was looking at the wrong place. So you guys should, if someone has a calculator, double check. But I was just looking at the wrong place in my notes. So this particular question is 0.11931. The previous one, I was looking in the wrong spot. So there are some errors here. So we'll have to go modify this one. So it's those two pieces there that are going to change. Jessica, is that why you were writing on my slide? You were trying to warn me? Here we go. So you're going to get this number here, which I'll read out in a moment. So for x equals 0 and having e to the negative 2.6, you're going to get 0.07427 times 1 divided by 1. So the answer here is 0.07427. I rounded to 3 here because I was like, well, that's 4 decimals. Okay, so there we go. Got to add these up, and we're going to go 1 minus these two answers. So when you add those up, go ahead, take them, add them together. These two numbers here, I got 0.2674. Okay, that's not the answer. We still have to subtract it from 1. So we're going to go 1 minus 0.2674. And that equals the probability that x is greater than 1 because of the complement rule. Okay, so when you finally type that in, you're going to get 0.7326. And again, that's equal to the probability that x is greater than, or just greater than 1. Okay, so it's kind of a long question, like not long calculation-wise, but because like I'm explaining it, kind of long. So, but I like that question. I really do. I really like it because it uses the complement rule. So that's part B. And I hope everyone's okay with that. Any questions about that? Part C, in our case, is actually, because of all the work we did in here, we actually already have everything we need. It says find the probability that no more than 1 bankruptcy occurs next year. So no more than 1. So that means that x would be less than or equal to 1, right? No more than 1 includes 1. So what is that? Well, no more than 1 would mean probability of 1 plus probability of 0. And that's familiar, right? We calculated those in part B. So all you got to do for this one is you could just say, see work in part B, because we did all the work there, and just write that the answer is 0.2674. I'm sorry, my 7 looks really ugly. Let's give it a facelift. Here we go. It is late, my friends. There, 0.2674. Okay. Any questions before I move on? Why isn't it showing my face in here? Does anyone know? Usually it shows whoever's talking, but I guess I can do this.
I hope it's not showing just my face.
No, well, on my screen it was just showing. It was showing like different people. I think. But yeah, there we go. Like usually, see now. Well, now it is just your face, Zach. Well, you know what? Because you're like one of the only people who turns on their camera, I'm gonna not do that to you. There. Okay, let's move on to the next one. All right, we're gonna show. I kind of like having my face. Oh, there we go. That's not bad. Well, let's try that. Okay. Now, what's this one all about? right? This is a quick question. It's really like, I don't put these in any particular order, but this would be a pretty straightforward question. So it just says, look, if you got n equal 20 and p equals 0.4 and it's a binomial distribution, what's the mean and what's the standard deviation? You know, this is basically a gift because all you got to do is be like, okay, you know, go look at your formula sheet, go look under binomial distribution. And by the way, this is the final formula sheet, but you guys can see here binomial probability distribution, and there's the mean or expected value. So it's n times p. And then there's the standard deviation. So it's really just grabbing those two formulas and working them out. So let's go ahead and do that, just to say that we did. So the formula for mean is mu equals n times p. And I don't have a lot of room, so when you do have to stay on one line, it is okay to use this arrow to signify like I'm moving to the next line on the same line. It's not great, but when you don't have any room, it can, you know, that transgression can be forgiven. So n is 20 and p is 0.4. So when you type that in on your calculator, you'll get 8. So that's the mean. It's just that simple. And then the standard deviation, I left a bit more room. So just grabbing that formula from the formula sheet, square root of n times p times 1 minus p. So, you know, show your work. Draw very crooked lines, but n times p, you know, we have it up here. That's 8. So you can write 8. And then 1 minus p is 0.6. So do the square root of that. If you have a moment on your calculator, I'll just kind of pause. 8 times 0.6 gives you 4.8. And then I'll just move over here. Oh, I'm writing the wrong symbol. We're doing standard deviation and I keep writing the mean. Should be writing standard deviation symbol. There, standard deviation, standard deviation, standard deviation, standard deviation. There we go. So square root of 4.8, 2.19. There. And there's no context in this question. We don't know what these numbers are about, so there's no units or anything like that. And we can move on to number 8. And number 8 is good old-fashioned, you know, binomial. It's all binomial distribution right now, but it's a good old-fashioned question where we're using this formula down here. Okay, so this one right here that I just highlighted. I think it's, well, next week we got a lab. So we're not learning anything new next week, but it's the week after that, I believe we look at the normal approximation to the binomial distribution. So that's a whole thing. And z-scores will be coming back. I don't know if you guys recall back in week 1, we went over this formula here. So yeah, we haven't covered any of this. This is the final formula sheet that I'm looking at. So yeah, just don't want you to be scared here. So let's take a look at this one here. What do we got? A manufacturer finds the probability that a given computer chip will fail is 0.02, and that's independent of other computer chips. Okay, so that's important because remember, things need to be independent for binomial distribution to work. Find the probability that of 5 delivered chips, exactly 2 will fail. Perfect. So if I was reading this in the context of like, you know, the end of the course, I'd be like, you know, this is a binomial distribution question because either a chip is going to fail or it's going to work. So whenever there's 2 outcomes, then you know it's binomial. So you're going to be using this formula here. And this is the one I was just showing you on the formula sheet. Okay, everything's being multiplied in here. So don't have to put the dots, but that's the formula we're using. And let's see, well, what do we got? N is 5. Right, says there's 5 chips, so n is 5, and in this case, x is 2. Probability of success is 0.02. So remember, don't get hung up on the word success being like, you know, a good thing. Like in this case, success is a computer chip failing. Okay, so how you phrase the question matters. So 1 minus p, if you want to pre-calculate that, you go 1 minus 0.02, you're going to get 0.98. So I like to make that little list before I go. I like to write my formula. You know, anything you can do to show me that you know what you're doing is good. If you make a mistake, then I'm not, then I can give you marks, right? So here we go. Just plug in the numbers. So it's going to be 5 C2. That's sort of how you read it. You can put brackets around that if you want. Now that's a button on your calculator, and what it's figuring out for you is if you have 5 items, how many ways can you choose 2 of them? So how many ways can you choose, 2 defective chips out of 5 and line them up? Okay, so if you type that in on your calculator right now, just because we're talking about it, you are going to get 10. So there's 10 unique ways to have 2 computer chips fail out of a group of 5. Okay, so that's some magic happening for us, basically. And then the next part of the formula. So we're going to go 0.02 raised to the power of x. And remember, x is 2. And then we have 1 minus p, so 0.98. So basically, 1 minus p is the probability that a chip is working, right? And that's raised to the n minus x. I generally just write that number. So 5 minus 2 is 3. I always sort of double check when you're doing one of these questions. This exponent, the 2, and this exponent, the 3, should add up to whatever n is. So n is 5. These 2 exponents should add up to 5. You can catch mistakes sometimes by doing that. So when you type in just this part, 0.02 raised to the power of 2, you're going to get 0.00030 zeros and then a 4. Okay, so a decimal and then 3 zeros and a 4. When you plug in this last part, again, it's kind of like how many decimals should you keep? Keep at least 4 in your work. So you can keep 5, like keep at least 1 more than what you're going to end up rounding to. So when you type that all in, you're going to get 0.0038. Now I am sort of missing something. In all of this, I should have been writing what this is equal to. So this is equal to the probability that x is 2. So probability that x is 2, probability that x is 2. There. So that is sort of the answer to this question. So pretty low chance. I would like to maybe extend. Yeah, we got some time. Let me just double check here. Yeah, we could probably do 1 extension on this question here. I actually came up with 2 extensions that I didn't write down. Let's see, which one should we do? Kind of one goes hand in hand with the other. We could always loop back. I'm just looking ahead because number 10 is a little long. Yeah, we can loop back to this one if you guys want to see some more. I have some extensions on this one. So, but we'll see it in number 10 anyhow. So number 9, this one pretty quick and straightforward, I think. According to the local newspaper, 40% of all employees have a university degree. If 6 employees were selected at random from a company, what's the probability that none of the 6 have a university degree? Okay, so how do I know it's binomial? Well, you either have a university degree or you don't, right? So there's 2 choices. That makes it binomial. Whether or not one person has a degree isn't going to affect whether the next person has a degree. So that all seems to be binomial. So that being the case, then you know that if it's asking for probabilities, you're going to be using this formula. It's always this one for now. And you can go ahead and write, well, what's the n for this question? It says if 6 employees are selected, so the sample size is 6, probability of success is 0.4. That's having a degree. 1 minus p is 0.6. There we go. Now, it's asking the probability that none of the 6 have a university degree. I think I assigned this question last year, like I gave it in like a lab or something, and a lot of people, I don't know what happened on this question. They weren't sure. They're doing sort of wacky things in my estimation, and I think it's because of the word none. So if I'm saying none of the 6 have a university degree, then I'm asking, well, what's the probability that x is 0? Okay, so for whatever reason, some people, more people than I would have expected, had trouble with that. So it's just, yeah, x is 0, and you're plugging it into this formula. So we're going to go 6 C0. So 6 choose 0 times 0.4 raised to the power of x. Just looking at the formula, and remember x is 0. And then 1 minus p, so 0.6 raised to the n minus x. So 6 minus 0 or 6. And this is the probability that x equals 0. Okay, so that would be your work. You could jump straight to an answer if you like. I sort of broke it down. So 620 is 1 times anything raised to the power of 0 is 1 as well. So if you remember those little shortcuts, that'll help you. And then 0.6 raised to the power of 6. Yeah, that's a little bit uglier. That's 0.046656. There. Kept an extra decimal or 2. And then obviously when you multiply it all together, you're just going to get this. So keeping 4 decimals is good enough. So there you go. All right. Yeah. Good, good, good. Zach, you like that one? Oh, you're smiling, so that's good. It's nice to have at least one person to talk to. Otherwise, I just feel like I'm talking to myself in a room here. So, all right, let's look at number 10. I'm very excited about this one, my friends. I'm very excited.
Aaron,
What's that?
may you go back to the last one for 10 more seconds?
Oh, sorry. Yes, I can. I'm very, yeah.
Thank you.
I got excited about the next question because it has Bernie Sanders in it.
All right, I'm good.
Perfect. Thank you very much for speaking up. So this one here, lots of work in this one, and complement rule comes in again, which is why I like it. I just love the complement rule. So Bernie Sanders buys his jacket once every 10 years from a local American manufacturer. So much for proofreading. Okay. The probability of having a defective jacket zipper in the first 5 years of ownership is 10%. All right. Always think to yourself, like I know we're not at near the end of the course yet, but always think to yourself, how would I know this is binomial, right? Because when we get to the end of the course, you guys are going to know a bunch of theories. Okay, when you look at a question, it may not be immediately obvious what kind of question it is. So the reason I was kind of giggling a bit was because I threw in this first 5 years of ownership. Some people might start to think that it's that it might be a Poisson distribution. Okay, but it's not, because we're not talking about time frames or anything like that. Like the time frame here is consistent, and either you have a defective zipper or you don't. You know, it could be Poisson. It's pretty borderline. It's pretty borderline, but it certainly could be interpreted using binomial. So that's an interesting one. I would like to rerun the numbers and see if I got a very similar answer with Poisson distribution, but I digress. It's binomial. So if 10 jackets are selected at random, what is the probability that 3 or more will have defective zippers in the first 5 years? Let's see. So if it is binomial, then we're going to have a p-value for probability of success. And in this case, probability of success is actually the zipper failing. And the question says there's 0.1 or 10% chance, so 0.1. N is 10 because we're choosing 10 jackets, and 1 minus P, so probability that the zipper works is 0.9. There you have it. And we're going to be using this formula, right? Take a moment to rewrite the formula every time, and that helps you memorize it a little bit, makes it a little bit faster. Now, probability to 3 or more. So we're going to have to think about this for a second. So X is greater than or equal to 3. Okay, so what does that mean? Greater than or equal to 3? Well, it would be probability of 3 plus the probability of 4 plus the probability of 5 plus, you know, dot, 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 until we get to 10. Probability of 10. So I'd have to go calculate, you know, all those different probabilities, which seems like a lot of work. So anytime you have like more than like, you know, 2 or 3 calculations in a question like this, you might want to look at the complement rule. So you can always use the complement rule, right? What would the complement rule be here? So you go 1 minus everything that's not included in here. So what's not included in greater than or equal to 3? Well, if we have 10 jackets, we could have zero zippers breaking plus probability of 1 zipper breaking plus probability of 2 zippers breaking. Okay, that's everything that's not included in greater than or equal to 3. So 0, 1, or 2. So it's going to be way less work to calculate these 3 probabilities rather than doing all of those. Okay, so I would go this route. And to show your work, I would do something like this. I would just sort of go, okay, here's probability of 0. And then I'm going to show my work here. And we'll go ahead and write it out. So it's going to be 10 choose 0. And then it's going to be 0.1 raised to the power of x, right? I'm just using this formula here. And then 0.9, and then n minus x is 10. Okay, so that gives me an idea of where I can start my next question. When you plug this all in on your calculator, just a few things like any time it's anything choose 0, the answer is going to be 1. Okay, and that happens more often than you think. So yeah, anything choose 0 is going to be 1. Anything raised to the power of 0 is 1. And then I just type that one in, and that would be my answer. So I got 0.3487. There we go. All right. And that's the probability that x equals 0. We also need probability that x equals 1. So very similar work, except it's 10 choose 1 because x is 1 this time. It's 0.1 raised to the 1. And then 0.9 raised to the power of 10 minus 1, or 9. So you can type that in on your calculator. 10C1 is 10. And anytime you have something C1, it's always going to be whatever n is. So if n is 10, it's going to be 10. If n was 50, it would be 50. 0.1 raised to the power of 1 is still 0.1. And then this thing here is 0.38742. So when you multiply that all together, you're going to get 0.38742 because 10 times 0.1 is just 1. Go. All right, we're almost there. Got to do x equals 2. So we go 10 choose 2. And then 0.1 raised to the power of 2. 0.9 raised to the n minus x. So 10 minus 2 is 8. Okay, so typing this all in your calculator, 10 choose 2 is going to be 45. And then 0.1 raised to the power of 2 is 0.01. And then 0.9 raised to the power of 8, 0.43047. There you go. Okay, there it is. Let's give you a moment to type that in on your calculator. When you do, if you're following along, you get 0.1937. Okay. So don't forget that we're not quite done yet because we're using the complement rule. So we need to add these all up. So over here, I'm going to kind of show the rest of my work. I'm going to write, well, probability that x is greater than or equal to 3 is equal to 1 minus all of this stuff. Now, you don't have to necessarily rewrite it because we wrote it up here. But when you add up these 3 numbers, you're going to get, what did I get? I got 0.9298. There we go. So 1 minus that number is going to be your final answer, and you're going to get 0.0702. Just rewrite this part, that x is greater than or equal to 3. And there you go. There's your final answer. So that's like a very complete, sort of like A to Z binomial distribution question. Could easily be anywhere between 3 and 5 marks, depending on, you know, what I want to make it, right? It could be 1 mark for using complement rule, and then 1 mark for each calculation, and then 1 mark for the final answer. So that would be 5 marks. Just to give you an idea of like what this could look like on a test or something like that. So, and of course, you'll see some in the lab next week. So there's a part B, and you know, we've already seen a question like this, but if 100 jackets are selected at random, what is the expected number of defective zippers? Okay, so n is 100, and we know that the probability of having a defective zipper is 0.1. So I'm just asking you the expected value, so that's the average. And your formula sheet literally says expected value on it if you're ever if you ever forget, like it literally says mean or expected value. There's different ways to word this question. Like I could just say, if you had like 100 jackets, how many defective zippers would you have, or something like that. So there are ways of asking it that are maybe a little bit more sneaky. Okay, but yeah, it's just a matter of multiplying 100 by 0.1. So that's not very hard. So you'll get 10 there. Okay, so it's 9:59. I don't want to hold anybody past 10 o'clock. I did mention that I had on number 8. I think it was number 8. No, number 7. No, my bad. It was number 8. That I had a couple extra questions. Very similar to number 10. I basically did that. So if anybody has any questions, you can ask them now. I will again put this video up on YouTube so that you guys can watch it again, and I'll put a link to it in Moodle, and I'll put these notes, the blank ones. Where should I stick them? I'll stick them in like I don't know, in the homework, not the homework. Yeah, I'll stick them in the homework section, I suppose. Actually, no, it's part of the lecture. I'll stick it in the homework section, but I'll also stick it in the notes. The notes section, so you'll find it everywhere. Any questions? Next week we have a lab. So instead of a video, you will get a link to a lab. So like some homework that you can then hand in on Moodle. Still not sure what it's going to look like in the online environment. I think I'm going to give you like sort of the traditional lab that I would have normally given you, and I'll give you solutions the next day or something like that. But there will be certain questions that you're going to hand in with your work. And you can work in groups of 2 for that. So you'll just have to indicate on Moodle if you are working in a group of 2, because everybody will have a place to hand it in on Moodle. I just ask that one person hands in your work as a group, and maybe just note in the comments, like, I was working with, first name, last name, student number. So I'll have those directions on there for you guys.
So this is all online, right? We don't have to go to Brandon.
Can you say that again?
We don't have to go to Brandon for the lab, right? It's online.
Yes, it will be online. Yeah,
Okay.
that's right. Yeah. It's a weird way to teach the course. This is my 4th or 5th time teaching it, and it's so weird to not be in class like in person together. But yeah, it is what it is. So I'm just
I have
waiting.
a question about my calculator.
Yeah.
So I have the BA2 plus, but mine only goes to 2 decimals. So what?
Is that a scientific calculator?
No.
Or is it like an accounting calculator or something?
Yeah.
And like accounting calculators usually don't have any of those math functions. Like you won't have factorial, you won't have like e to the x, like Euler's number. You won't have combinations, like the 10 choose 0. Is that the case on your calculator?
Yeah, I'm guessing
Yeah.
so. I have a scientific calculator somewhere. I just figured I'd ask.
Yeah, you're definitely, for this course, you're definitely going to need a scientific calculator. It doesn't have to be a fancy one. Like you can go buy like a good like $15 scientific calculator at Walmart, or you can have one of these, which is just stupid, way beyond what you need for the course. But yeah, just a regular. Make sure it says scientific calculator, and make sure it has Euler's number, factorials, and combinations. That's this thing here that I'm pointing at, and yeah, you'll be good.
Okay.
So I'm just sticking around for as long as people are here. Like if you have questions, I'm sticking around for that. Somebody asked on Saturday, they were looking for week 2, 3.4. There wasn't a solution for 3.4. So I actually uploaded that to Moodle. So thanks to that person for asking and pointing out. If you ever notice anything like that, let me know, and I'm happy to, you know, put the solution up. You'll notice that this week will be one of the first weeks where there are detailed solutions that are written out by me. I'm sorry, some of the pages scanned upside down. So like if you're looking at them online, like you either have to tilt your head or, you know, print them or something like that. Or take a picture with the snipping tool and flip them. I don't know why my scanner did that. Anyone else with questions? Course is going okay? Like you guys are happy?
Sir?
Good, good, good.
Sir, about the bonus assignment,
Yes.
I had tried submitting it, but I don't think you got it. Can I try sending it to you again, or
I can certainly check and see. Let me just.
because like I did it a picture from my phone, and so I was trying to submit it by my phone, but it doesn't work. Looks like it's like sending.
Okay. You know, in the meantime, if you want to just send me an email with it just in case, and then I'll see if it actually did get handed in on Moodle or not. But yeah, maybe just send it to me via email.
Okay, I think I handed it on Moodle, but I'll try sending email again too. If you, I don't know if you could check now or.
Yeah, just in case. I can go check. I actually can't recall on Moodle where that's going to be, so it might take me a bit longer to find it. Let's see. If I click on it, let's see. Yeah, view all submissions. What's your last name, maybe?
Lewis.
Okay, that didn't come up when I did a quick search. I'll just quickly. Oh, but it's okay. It doesn't look like it's on that page. It's giving it to me page by page, so I have to check every page. There we go. Yes, it looks like you did.
All right, perfect. Thank you.
Thank you. No problemo.